I'm a physics major at UNC, and I'm going to talk to you a little bit about photoelectric effect. So does anyone know what the photoelectric effect is, or has ever heard about the photoelectric effect? Okay, good. I didn't think so. So basically, what the we have what? No. Okay. So what the photoelectric effect describes is basically that that electrons are emitted from solids, gases, or liquids when they're exposed to light. Right. These things are called photoelectrons. Funny enough. And this phenomenon was discovered in 1887 by a guy named Heinrich Hertz. And he had a very simple experiment. So I'm sure that you all are a little bit familiar with circuits. So I'm going to draw one very simple here. This is basically just a wire with a gap in this somewhere, with two metal plates, right? And so what he did was he shone light on one of these plates and noticed that there was a current in the circuit. And all a current is a measure of electrons over time, right? So he did this and noticed that there's something going through here. There was no power source, so something had to be happening. Electrons were being emitted from one side and moving across to another. So the next thing he did was he did add a power source in here, like this, right? This is some voltage Vs. I'm just going to use Vs for now. And what he used this for is to cancel out the current that was coming from these emitted electrons. I use Vs because this is what he referred to as the stopping voltage, right? So this is the amount of voltage it took to stop this current that was coming out. And the way this works is that it provided a potential difference, a difference in voltage between these two plates that was basically equal to the amount of potential in these electrons. So all that means is that each of these electrons that was emitted had some amount of kinetic energy, right? That was equal to, well, I'll put it on the side. It's proportional to this stopping voltage by the max kinetic energy of any of these electrons is equal to EVS, where E is the charge of an electron and Vs is this stopping voltage that Hertz found. Alright, so in the experiment, outside of this, what do we expect to happen when light is shown on like a metal plate, for instance, like in the experiment, according to classical physics? I'll go ahead and, yes? You have any ideas? It heats up. Yeah, actually it does.
Sally.
What's up? Any other suggestions? Why do you think electrons shoot off of this plate when light shines on it? I don't know. Any ideas? So you all are familiar with electrons being a part of an atom, right? And they're held into this atom with some amount of energy, right? So that energy is going to be very important. We're going to come back to that. But what physicists at first thought was the reason for this, and what they thought was going on, basically can be summarized in 3 points. So the first is that the intensity of light is important, right? And the bigger intensity, or the greater intensity light that is shown on this plate, or this surface, or whatever it is, the greater the kinetic energy will be. So that was one of their first postulates. The second one was that intensity is really the only thing that matters, and that wavelength or frequency of light does not matter. So the idea is that you can use blue light and make it really bright and make these electrons come off with a lot of energy, or you can use red light with very dim light, for instance, and the electrons, if they came off at all, wouldn't come off with very much energy. So frequency doesn't matter. Only intensity matters. And the last thing actually has to do with the heating up. Physicists thought that it would take like a second for the plate to heat up and get enough energy for these electrons to come off, right? And they thought that there would be a time delay. of about 1 second. Right? And these are all things that physicists thought were going to happen. This is what they thought was going on with these plates and why electrons were coming off and what was related to what here. But when they actually did the experiment and when they tested for all these things at around the turn of the 20th century, what they found was a little bit different. So the first thing up here is that they found that the intensity actually doesn't affect the kinetic energy of the electrons, right? Which is the exact opposite of what we wrote up here, right? Intensity does not affect kinetic energy of electrons. What intensity does do, however, is affect how many electrons are coming off, right? So as intensity increases, the number of electrons emitted increases also. But what they also found, as far as the kinetic energy of these electrons, is that they are dependent on frequency. So as the frequency of the light shown on whatever the surface was increased, so did the kinetic energy of these electrons that were coming off. So what we have so far is that as intensity increases, the number of electrons shoots up, and as the frequency increases, the kinetic energy of these electrons comes up. The last part has to do with the time delay, and they found that it was almost instantaneous. Right? So as soon as the light was shining on this surface, electrons were emitted with a time delay of about 1 nanosecond, which is tiny, very small.